Hi friend, today my discussing topic is about related to the different competitive examinations of engineering category. So today my discussing topic is DC basic and networks. And this digital videography will help you to memorize all the questions very carefully for remember and take in the examination of competitive category. So let's start about the discussion. The first questions is charge on an electron is 1.602 into 10 to the power minus 19 coulomb. An electron having mass m kg and charge e coulomb travel from rest through a potential difference of V volt. It has a kinetic energy of EV joules. The flow of electric current in a conductor is due to the flow of electron. An electric current is the movement of free electron predominantly in one direction. The practical acting as current carrier in a metallic conductors are only electron. In gases, the flow of current is due to electrons, positive ions and negative ions. Flow of how many electrons per second will produce current of 1 ampere. 6.25 into 10 to the power 18. Ampere second could be the unit of charge. 1 coulomb charge is equal to the charge on 6.25 into 10 to the power 18 electrons. The charge Q flowing through a conductor carrying current of I ampere for t second is equal to I into t coulombs. The minimum requirement for causing flow of currents are a voltage source and a conductor. Which of the following current is considered dangerous for human body? 50 milliampere. The ampere is the current which, if maintained in two straight parallel conductors of infinite length of negligible circular cross-section and placed 1 meter apart in a vacuum, would produce between this conductor a force of 2 into 10 to the power minus 7 Newton. Current velocity through a copper conductor is of the order of a few micromillisecond. The draft velocity of electron is very small in comparison to the speed of light. Voltage is a form of potential energy. 1 volt is equal to 1 joule per coulomb. Electric pressure is also called the voltage. Resistance of human body is about 1000 ohm. The ratio of voltage and electric current in a closed circuit remain constant. If in a circuit the voltage is reduced to half and resistance is doubled, the current will be a quarter. The condition for the validity under Ohm's law is that temperature should remain constant. The curve representing Ohm's law is linear. Ohm's law is applicable to semiconductor, vacuum tubes, electrolytes, carbon resistors, arc lamp, none of these. A linear resistor is one which obeys the Ohm's law. Which of the following statement is correct? Regarding resistance, the resistance of a conductor is the hindrance by which the conductor opposes the flow of current through it. The resistance of a conductor having length L, area of cross section A, and resistivity zeta is given as zeta L by A. Resistance of a wire always increases if number of free electrons available become less. The resistance of wire varies inversely as area of cross section. The resistance of a conductor increases as its cross-sectional area decreases. For a fixed supply voltage, the current flowing through a conductor will increase when its length is reduced. Two wire A and B of same materials and length L and 2L having radius R and 2R respectively, the ratio of their specific resistance will be 1:1. The electric conductivity of metal is typically of the order of 10 to the power 7 ohm minus 1 meter minus 1. Pure metal generally have high conductivity and large temperature coefficient. There are two wires A and B. A is 20 times longer than B and has half the cross section of that of B. If the resistance of B is 1 ohm, the resistance of conductor A will be 40 ohm. The diameter of wire is reduced to 1/2. Keeping the length constant, the new resistance will be 4 times of the original. A cylindrical metal rod has resistance of R ohm. It is now reformed to 3 times its original length. Keeping the volume constant, the new resistance will be 9R. The wire is stretched to its double the length. The new resistance will be 4 times the original resistance. The length of wire having a resistance of 1 ohm is cut into 4 equal parts, and these 4 parts are bundled together side by side to form a wire. The new resistance will be 1/16 ohm. The resistance between the opposition faces of one cube is found to be 1 ohm. If its length is increased to 2 meter with its volume remaining the same, then its resistance between the opposite faces along the length is 4 ohm. A wire of length L and a circular cross-section of radius R has a resistance of capital R ohm, and another wire of same material and of cross-sectional radius 2R will have the same resistance R if the length is 4L. If the diameter of the wire is halved, its current carrying capacity will become about 1/4. Specific resistance of a conductor depends upon composition of conductor material. Which of the following material possesses the least specific resistance? Silver. The resistivity or specific resistance is measured in ohm meter. The specific resistance of copper is 1.76 into 10 to the power 8 ohm meter. electric conductivity is measured in mho per meter. The substance having a large number of free electrons and offering low resistance are called conductor. The material having a few number of free electron and offering very high resistance to the flow of electric current are known as insulator. With the increase in temperature, the resistance of pure metal increases. With the rise in temperature, the resistance of carbon decreases. With the rise in temperature, the insulating property of an insulator weaken. With the rise in temperature, the temperature coefficient of resistance decreases. The value of temperature coefficient of resistance of a given conductor are different at different temperature. Temperature coefficient of resistance is defined as increase in resistance per ohm per degree Celsius. Which of the following quantities are the same in all part of a series circuit current? Which of the following statement is false in case of series circuit? The voltage drop across each resistors is the same. Two resistors of 12 ohm and 4 ohm respectively are connected in series. A short is placed across the combination. A short is placed across the combination, the effective resistance will be 0. If in the above figure R1, R2, R3, R4 and a voltmeter is placed between R3, resistors R3 becomes open circuited. The voltmeter will read 250 volt. Two resistance of equal value when connected in parallel give an equivalent resistance of R. If these resistors are connected in series, the equivalent resistance will be 4R. Thank you friend for your memorizations. I have do the 60 questions in one video. Thank you very much and subscribe my channel. Thank you.